This is the lesson video for concept 36. This is parallelograms. So write your name, and then for topic you're going to write in concept 36. So there's a couple things that we need to note here. Okay, the main properties of parallelograms. So pay close attention what these 5 properties are, because it's going to make all these problems easier if you understand it. So before we write these in, let's draw out what a parallelogram is. So using a straight edge, if you have one, you're going to draw the following quadrilateral here, okay, and do your best to make it as accurate as possible. So the particular thing about a parallelogram is it's a quadrilateral. We have 4 sides, and each pair of opposite sides are parallel. Okay, that's where the name comes. In other words, this side here is parallel to this one. They do not intersect if you extended them infinitely. And then the other pair of opposite sides, those there, here, those are also parallel. Okay, they do not intersect. So let's write our first property. The thing about these things, these figures, is that opposite sides are parallel, as I just explained. Opposite sides are congruent, and that means that each pair, again, so this side here is also equal to this side here. This side is equal to this side here. That's what the second property means. The third property is that opposite angles are congruent as well. So let's label our parallelogram here. We're going to start with A, B, C, and D. This means the third property that opposite angles, so angle A and angle C, are equal, and angle B and angle D are also equal. The fourth property is that consecutive angles are supplementary. And in supplementary, recall, it means that they add up to 180 degrees. And what do I mean by consecutive angles? It means that the angles that are next to each other add up to 180 degrees. So angle A plus angle D is equal to 180. Angle D plus angle C is equal to 180. Angle C plus angle B is equal to 180. And then angle B and angle A is also equal to 180. The last property here is that the diagonals bisect each other. Now, bisect is a new term. What I mean by bisect is if you draw in your diagonals, and I'm going to use a different color here. I'm going to draw them dashed. Okay, the diagonals are the lines you can draw between opposite vertices. So that's one diagonal, and here is the other diagonal. And what I mean by bisection, okay, that they bisect each other, is that when the diagonals meet here at the center, okay, these two segments, the diagonals were cut. Okay, we have this piece here, this piece here, and this piece here, and this piece here. Okay, what we mean by bisection is that you've cut the segment, or the line, the diagonal in this case, into 2 equal parts. So this side here is equal to this side. Okay, So A to the center is equal to the center to C. Okay. Similarly, the longer diagonal, this side here, okay, so from D to the center, okay, is equal to the center to B. That's what we mean by bisection. Whenever you see bisection, is that you have a segment that was cut into two equal pieces. So let's look at our first example here. It says directions. Each quadrilateral below is a parallelogram. Find the missing measures. So let me move this down a bit so we can look at our properties. We have AB, so we're looking for these measures here, or missing lengths. AB is 15. Okay, so then I know, and this is property 2, opposite sides are congruent, they're equal. So if AB is 15, DC, the opposite side here, is also 15. So the first one is 15. DC, whoops, AD is here. So if BC is 8, the opposite side here is also 8. I apologize for that. So then AD is 8 and DC is 15. Angle A we do not know, but we do know angle D. Angle D here is 68 degrees. We're going to use property 4. Consecutive angles are supplementary. So then this angle A plus this angle need to equal to 180 degrees. So if you do 180 degrees minus 68, that gives you this measure here. And if you do that in your calculator, you're going to get that angle A is 112 degrees. So 112 degrees there. Angle B, okay, that's this one here. You can do the same idea, consecutive angles are supplementary, but we can actually just use property 3, opposite angles are congruent. So this one is 68 degrees, so then this one here is also 68 degrees. Similarly, angle C, if this one's 112, then the opposite one is also 112. For number 2, it says same idea. We're finding JK, KL, and then 3 angles. Okay, so maybe before we fill this out so we can avoid errors like I did here, let's just go ahead and fill in the picture. So ML is 21. The opposite side to this one is JK, so this one is also 21. This side here is 29, so then this side here is also 29. I have one given angle, so I can just take any consecutive angle, either this one or this one, and I could find, because they're supplementary, that's property 4, I can find the measure of the angle. So they need to add up to 180. I'm going to take angle M plus this one, add up to 180. 180 minus 127 gives me angle M. So if you do that in your calculator, you're going to get 53 degrees. So angle J is opposite to angle L, so then this one is 127 degrees. Angle K is opposite to angle M, so this one is also 53 degrees. Now you can go in and fill in based on the information we found here. We have 21 here, 29 here. Angle J is 127 degrees. Angle K is 53 degrees. Angle M is also 53 degrees. Number 3, what changes here is that now we have our diagonals drawn in. So let's take the same approach and start filling in as much as possible before we fill in the sides here. Okay, so RU is opposite to ST, so then they're both 18. RS is 27, so then UT is also 27. And they give us a bit of information here. They tell us that RT is 30. RT is this diagonal here. Okay, and like we said, they're bisected. Okay, so when they met here, this side here and this side here are they're equal. So you cut it in half. So if the entire thing is 30, then 1/2 is 15 and 1/2 is 15, because 15 plus 15 is 30. They do tell us that this one here is UV is 7, so then VS is also 7. And that's everything that we can figure out from here. So then we can go ahead and fill out the right side here. So UT is 27, ST is 18, VS is 7, and VT is 15. Number 4, instead of working with sides, dealing with diagonals, in this case now we have angles we have to figure out. So these can get a bit tricky because they do pull in, some of these problems will pull in the idea of alternate interior angles. So they tell us that this small angle here, CFG, okay, CFG is here, is 21 degrees. They tell us that GEF is 71 degrees, and FED is here. So this bigger angle here is 134. So we can actually use this information here given to find the other angle. So if this side is 71 degrees, okay, this angle here, that one that I just drew in, they need to add up to 134. The entire thing is 134, part of it is 71. So if you do this in your calculator, okay, you can find what the measure of the other angle is. So you do 134 minus 71, you get 63 degrees. So this one here is 63 degrees. This angle is opposite to this one, so the entire thing, okay, also has to be 134 degrees. Let's pause before I draw that in so that we don't do any extra work and we know exactly what we're looking for. So the measure, we want the measure of DEC. DEC, okay, it's right here, the one I'm outlining here, and we actually already found it. It's 63 degrees. The next one is CDE. CDE is this one here. So let's think. What do I need to find first to be able to figure out what this entire angle here is? So okay, so what we need to do is we're going to use property 4, consecutive angles are supplementary. We know that this entire angle here is 134 degrees. So then this angle, the entire thing here that I'm outlining, okay, plus this angle here need to add up to 180 degrees. So we know that the entire thing is 134, okay, 71 plus 63, 134, plus 21 plus an unknown angle. Let me use red here, and we'll call that one X for the time being, okay, add up to 180 degrees. So 134 plus 21 plus X is equal to, not 134, I meant to say 180 degrees because they're supplementary. Okay, and I know I wrote it kind of small, so you have 134 plus 21 plus X equal to 180. Combine these two and then subtract from 180. When you do that, you're going to get 25 degrees. So then angle GFE, okay, this small one here, let me write it in red, is 25 degrees. Okay, let me zoom in here. Okay, so I have 25 degrees there in red. So then I can now, I think I found enough information to be able to find the rest here. So CDE angle CDE, the entire thing here, okay, is opposite to the entire angle here. Okay, so I have 21 plus 25, that gives me the entire angle. That's equivalent to this one. 21 plus 25 is 46 degrees. Angle ECD, here, okay, we can actually use, so first is, we know this angle is opposite of this, so they are also equal. Okay, we can actually use the idea of alternate interior angles so that we can figure out what ECD is. If I rotate my paper slightly so this looks straight, okay, so here's the one line, I'm extending this line, okay, and I'm extending this line here as well, okay, and then here is my transversal, this line here, okay. So if this angle here is 71 degrees, then this one here would be the alternate, let me zoom in a little closer, this one here would be my alternate interior angle to this one here. So if this one is 71 degrees, this one here is 71 degrees. So that is angle ECD. Angle DFE, so here's D, here's F, here's E. DFE is 25 degrees. We already found that one, okay, so we can actually, and then just bonus, we can use that same idea, okay, for this one here, so that we can use alternate interior angles to find this measure as well. And if I rotate slightly again, if I extend this line, if I extend this line, here's my transversal, okay, I can say that this angle here is alternate interior to this one here, so they are both equal. This being able to use, so let's put a star, being able to use alternate interior angles, okay, will make these problems a lot easier. Moving on to number 5 now. Let's see here. It says given xy is 15, so let's write that in to make things easier. Xy is 15, wx is 22, zx is that's the diagonal here, the entire diagonal is 32. I won't write that in because I don't want to make things sloppy here, but maybe we can write in the bisected segments instead. So if the entire thing is 32 and we have a bisection here, then each thing here has to be half of 32. Half of 32 is 16. So this side here is 16, this side here is 16. WT is the other diagonal, it's 10. No, sorry, WT is this right here, this smaller portion of the segment here. It's 10. It's half of the diagonal WY, and we know that they are bisected, so they are both the same. So that side's 10, that side is also 10. WZY, angle WZY, here's WZY, so it's the entire thing here, is 62 degrees. Then it says the measure WXT, so it's half, not half, but this angle here is 27 degrees, and measured, maybe we should write it in, I'm going to write this in red. So this one is 27 degrees, 27, the previous angle was 62, so that's the entire thing, 62 degrees. And we have the final one, ZWT. So ZWT is ZWT here, this angle here, is 77 degrees. So this one is 77 degrees. Okay, so we can, let's see, let's start with this angle here in the bottom left, 62 degrees. This one is opposite to this entire thing here. We know part of it is 27 degrees, so we can figure out what this one is since we know they have to add up to 62 degrees. So 27 plus an unknown is equal to 62. If you just do 62 minus 27, you can find the measure of this angle here. So 62 minus 27 is 35. So then this angle is 35 degrees. And again, because when you add them up, they have to equal this one because they're opposites, so they're equal. So now let's see, we can use the idea of alternate interior angles to figure out a few of the other angles here remaining. So if I have, maybe I should rotate my paper this way. Okay, let's see. Maybe we can think about it vertically. So if I extend these lines here, okay, the ones I'm tracing here with my pen, here's one line, here's the other one, these are parallel, and if I count this line here, WY, and I extend it, that's my transversal. Okay, so then this angle here is an alternate interior angle to this one here. So ZWY is 77. This one here is also 77 degrees. Okay, and then we know, and we could have started with this actually, we know that this angle here and this angle here, these are consecutive, so they have to be supplementary. Okay, that's a property we have as part of our parallelogram properties. So 62 plus this unknown here plus 77 have to equal to 180. So I can do 62 plus 77 plus x equals 180. And when you do this in your calculator, when you solve for x, you're going to get you get 41. So x is 41 degrees. This one here, this small one, is 41 degrees. And you can use the same idea of alternate interior angles now, looking at it this way, so that this angle here is also 41 degrees. So now I think we have enough to be able to fill out everything. ZW is here. Actually, I didn't even fill this one in. It's opposite to this angle here. Sorry, this side here. So XY is 15. WZ is also 15. ZY is, well, WX is 22, so then the opposite side here is also 22. TX is right here. We already labeled it as 16. That was one of the bisected diagonals. WY is here, the entire thing. We know each part is 10, so 10 plus 10, you get 20. The measure of angle TZY, here's TZY, okay, that one is, and we didn't label it specifically, but this one is alternate interior to this one up here, the one I'm pointing at, so it's 27 degrees. Measure of XYZ, XYZ is this angle here, okay, the big one. You add these two up, and then that gives you the measure of that thing. So it's 41 plus 77. Do that in your calculator, you're going to get 118 degrees. So the entire thing here is 118 degrees. XWT, here's XWT, the small one here, we already have it, it's 41 degrees. XYT, getting mixed up with the letters here. So XYT is this angle here. We already have it as well. It's 77 degrees. Okay, and that wraps up number 5. Looking at number 6, we have GHF. GHF is 34 degrees. GHF is here, so it's this angle here. We have 34 degrees. HJF, here's HJF, so it's the entire thing. We have 124 degrees. So let me do this in red. Okay, so the entire thing is 124 degrees. And then the measure FKJ, so it's actually one off the center there, is 79 degrees. That one is 79 degrees. So we can, let me see, let's just go ahead and start labeling in based off alternate interior angles. So if I extend this side here and this side here, okay, this line here is my transversal, so then this angle here that I'm tracing is alternate interior to this angle here. So if this one's 34, this one here is also 34 degrees. Now I can find this angle here because this one here and this one here, they're supplementary, they have to add up to 180 degrees. So if I do 124 plus 34 plus x is equal to 180 degrees, and you solve, you're gonna get 22 degrees. So then this one here is 22 degrees. And then now, you know, it's important to have the idea of the alternate interior angles, but you can pretty much match. If this one is this one here, and if we know that they're opposite angles, so they have to be equal, so then this angle is this one here. So this one's also 22 degrees. If we move over to the center, okay, we have a key idea here that's coming back. Okay, we have an X, the bottom is 79 degrees, we have vertical angles, so then this top one here is also 79 degrees. And for now we can say that if this one here is 124, then the opposite angle here, okay, is also 124. So let's look at what they're asking before we continue. GFJ is this entire thing here. Okay, so we have 22 plus 34, that's 56 degrees. FGH, we have FGH, that's opposite to this angle. If this entire thing is 124, this entire thing is also 124. So we have that one as well. HFJ, so here's HFJ. Okay, so we have that angle. HFJ is 34 degrees. HKJ, here's HKJ. Okay, so it looks like we do need to now go back into our figure and figure out what this angle is. Now there's multiple ways you can look at it. I would say the one that's maybe the best way to look at it is this idea is also one we covered. Okay, I'm using blue now. We know that if we go full round here in these angles, they have to add up to 360 degrees. Or you can look at it, this is a straight line, right? So then this angle plus this angle, it's a straight line, they add up to 180 degrees. Okay, so 79 plus this angle add up to 180. So then this angle would be 101 degrees. because 101 plus 79 give you 180 degrees. So then HKJ is 101. Also, you have vertical angles here. So if this one's 101, you also have that this one here is 101 degrees. So continuing, we have JGH. Here's JGH. So now they're asking for just part of an angle here. So one way we can look at it is we can consider that this here is a triangle, right? And we know that the three angles inside a triangle add up to 180 degrees. So we can use that property to find this angle here, because we only have the entire thing here, okay, 124. We don't know how to partition it yet. So we can think of this triangle here. You can also think of this entire triangle here. So 22 plus 34 plus this angle add up to 180 degrees. So so let's take the smaller triangle, 79 plus 34 plus this one here, okay, add up to 180. And if you do that in your calculator, so let's use green. Okay, green is 79 plus 34 plus an unknown. Let's call it y, because I already used the x, equal to 180. We find that that angle there is equal to 67. So y is equal to 67 degrees. This one here is 67. So we have this one. You can also think of it as alternate interior angles between this, and so then this one corresponds to this one here. So then this one is also 67 degrees, and we know they add up to 124 degrees. So you can find the other angle here, and it's getting pretty crowded, so I'm just going to write it up top here. Okay, 67 plus an unknown give you 124 degrees. So if you do that math, you get 57. So then this angle here is 57 degrees, as well as this one here. 57 plus 67 is 124. So continuing, I have FGJ. FGJ is 57. FHJ. FHJ is 22. And then finally GJF. So here's GJF is 67 degrees. That's the one we found in green. Okay, and this wraps up number 6. If we go to the next page here, we have now algebraic expressions and parallelograms. Okay, it's still using the properties from page 1. We know that opposite sides are equal, so this side is equal to this side. It says solve for x. They're equal, so 9x minus 25 is equal to 5x plus 7. Okay, and then you solve for x, send my x's to one side, your constants to the other side. So I'm going to subtract 5x from both sides here. Those cancel. I get 4x minus 25 is equal to 7. Add 25 to both sides. I get 4x is equal to 32. And when I divide by 4, I get that x is equal to 8. And I do not need to plug back in because it's asking me just to find x. To find yz, yz is this one here. Okay, it's opposite to this one, so I can set these two equal to each other and I can solve for x. So I have 11x plus 1 is equal to 19x minus 31. I'm going to get my x's on one side, my constants on the other side. I'm going to subtract 11x from both sides here, and I get 1 is equal to 8x minus 31. Then I add 31 to both sides, and I get 32 is equal to 8x, and when I divide by 8 there, I get that x is equal to 4. Now, I'm not done. Okay, it says find yz. So now that I found x, I have to go and plug back in. Okay, so yz is equal to 19x minus 31. Plug the x in that I found, 19 times 4 minus 31. And then when you do that in your calculator, you're going to get 45. So this is the final answer. 45 is the value. Number 9, it says if TV is equal to 74, TV is this diagonal here. If that's equal to 74, and if WV, where's WV? Here's WV. WV is 4x plus 1, solve for x. So WV is half of TV. Okay, it's half. So there's a few ways you can set this up. If TV is 74 and WV is half of TV, you can say that 2 times WV is equal to the entire thing, because again, they're bisected, so those two are equal. So if one is 4x plus 1, the other one is also 4x plus 1. So you can do 4x plus 1 times 2. So 2 times 4x plus 1 is equal to the entire thing, 74. Distribute the 2 in, you get 8x plus 2 is equal to 74. Subtract 2 from both sides, you get that 8x is equal to 72. And divide by 8, you get that x is equal to 9. And they're asking us to just solve for x, so I'm done. Number 10, it says if ns is equal to 2x plus 7, so that's this segment here, part of the whole diagonal. Okay, so same idea as the previous one. SQ is 5x minus 23. It says find NQ. So NS is 2x plus 7. SQ is 5x minus 23. We know these are bisected, so they are equal. Okay, and I can set them equal to each other to find what x is. So 2x plus 7 is equal to 5x minus 23. Get my x's on one side. I get 7 is equal to 3x minus 23. Add 23 to both sides. I get 30 is equal to 3x. Divide by 3 and I get x is equal to 10. X is equal to 10, but I'm not done. Okay, so there's multiple approaches you can take here. I can plug in 10 to just one side and then double it, and that gives me the value of the entire thing, right? Because they're equal. So NS is equal to 2x plus 7. So I can plug in 2 times 10 plus 7, and this gives me 20 plus 7, so I get 27. So that's NS. They want NQ, the entire thing, and again, this is half of the entire thing. So if you just double this, that gives you the final answer. So NQ is equal to 54. Number 11 says to find the measure of angle B. Angle B is here. Okay, we know that these two are equal, so because they're opposite angles, so 6x minus 15 is equal to 4x plus 11. I subtract 4x from both sides and I get 2x minus 15 is equal to 11. Add 15 to both sides. 2x is equal to 26 and I get that x is equal to 13. Now I can plug 13 back into one of these, okay, and then use the property of consecutive angles equal 180 degrees. They're supplementary. So angle A, I'm just going to use angle A, I get 6 times 13, I'm plugging in for x, minus 15, and when you do that, you're going to get 63 degrees. So angle A is equal to 63 degrees. Now we know that this angle and this angle are supplementary. Okay, so you can call it x. You can call it, well, we already used x. You can call this call it y for now. Okay, so y plus 63 degrees are equal to 180. So then minus 63 from both sides, you're going to get that the measure y is 117 degrees. That is angle B, right? Y is angle B, so angle B is 117 degrees. And you're done. To find angle R, angle R is right here, same idea. Well, actually slightly different. Okay, so this is angle Q, this is angle P. We know that these two are supplementary because they're consecutive, they're next to each other. So 8x minus 12 plus 3x plus 5 is equal to 180 degrees. 8x plus 3x, I get 11x. Negative 12 plus 5, I get negative 7. That's equal to 180. Add 7 to both sides. I get 11x is equal to 187. Those canceled. Then I divide by 11, and when I do that, I get x is equal to 17. Now, because I want angle R, and I know angle P, these two are opposite, so they have to be equal. I can plug into this one, and then that gives me angle R. So measure of angle P is equal to measure of angle R. So the measure of angle P is equal to 3 times 17 plus 5. Again, I'm plugging into this one. Okay, I get 51 plus 5, and that's equal to 56. And we already said that they're equal, so then that's my answer. We're almost there. Angle 13. The problem 13, sorry. Measure of angle KLH is 134 degrees. So KLH is this entire thing here. So then this angle here, because it's opposite, is also equal to this one. And then it says just solve for x. So let's see. We can say, okay, let's use alternate interior angles here. Or actually, yeah, let's use alternate interior angles. So this is, if I consider these here as my parallel lines, this line here is my transversal. So then this angle 4x plus 5 with this one here, okay, are alternate interior angles. So this one is also 4x plus 9. 4x plus 9. So then and I know that this entire thing here, let me use red, is 134 degrees. Okay, this and this are supplementary. This entire thing with 134 degrees are supplementary. So I can use that expression to solve for x. So 25 plus 4x plus 9 plus 134 are equal to 180 degrees. Combine my like terms, 25 plus 9 plus 134. I get, let's see, use your calculator. Plus 9, I'm getting 168, so 4x plus 168 is equal to 180 degrees. And then I subtract 168 from both sides, and I get 4x is equal to 12, so x is equal to 3. Last one in this part, I have the measure of angle ABC is 115, so ABC, the entire thing is 115. Find the measure of angle ADB. ADB is part of it, yeah, just half here of the opposite side. So I know the whole thing is 115. Let's see, you can use alternate interior angles again. Here, AD, if I extend AD and BC, and then consider this this line here, BD, as my transversal, then I know that this side and this angle here those are my congruent pairs. So this angle is equal to this angle is equal to this angle. And then let's go ahead and use ABC, because that's the one they're telling us is equal to 115. So if that's 4x plus 6, and these two are alternate interior, then I know that this one here is also 6x minus 11. So 4x plus 6 plus 6x minus 11. Okay, so both angles equal to 115, because that's what they tell us, the entire thing is 115. 4x plus 6x, I get 10x. 6 minus 11, I get negative 5 is equal to 115. Add 5 to both sides, I get 10x is equal to 120. And then when I divide by 10, I get x is equal to 12. But I'm not done. It says find the measure of angle ADB. ADB is this expression here, 6x minus 11. So then you plug in 6x times 12 minus 11, 72 minus 11, you get 61. So 61 degrees is, 61 degrees is the final answer here. That wraps up part 1 of concept 36 on parallelograms.